Imagine you're standing outside after a storm. The sky clears, the sun breaks through, and suddenly a rainbow. You've seen it 1,000 times, but have you ever asked yourself one simple question? Why exactly 7 colors? Not 6, not 8, not infinity, 7. Turns out the answer has less to do with physics and more to do with one scientist's obsession with music. And the number 7. Buckle up, because this story is weirder than you think. First, let's get one thing straight. Rainbows aren't actually there. You can't touch a rainbow. You can't walk to it. It's an optical illusion, a trick your eyes play when light bends through water droplets. Here's what actually happens. Sunlight, which looks white, is secretly a mixtape of every color. Red, orange, yellow, green, blue, they're all crammed in there together. When white light hits a raindrop, it slows down, bends, and splits apart. Each color bends at a slightly different angle because each one has a different wavelength. Red light has the longest wavelength, so it barely bends. Violet has the shortest, so it bends the most. The result? A perfectly organized spectrum of color. And here's something wild. Rainbows are actually full circles. And here's something wild. Rainbows are actually full circles. We only see arcs because the ground blocks half of it. If you're in an airplane, you could see the whole ring. Even crazier, bees see ultraviolet light, which means their rainbows look completely different from ours. If a bee could paint what it sees, it would blow your mind. So who decided rainbows have 7 colors? Sir Isaac Newton. The same guy who discovered gravity? In the 1600s, Newton was obsessed with light. He passed sunlight through a glass prism and watched it split into colors. At first, Newton counted 5 colors: red, yellow, green, blue, and violet. But then he had a weird thought. Music has 7 notes in a major scale, and 7 is a mystical, sacred number. So Newton thought, why not make the rainbow match music? He added orange between red and yellow and indigo between blue and violet. Boom. 7 colors. Problem solved. Except, did Newton actually see orange and indigo as distinct colors? Or did he just force them in because 7 sounded cooler? We'll never know. And here's the kicker. Not every culture even agrees on 7. Japanese tradition recognizes only 5 colors, skipping orange and indigo entirely. Some African cultures see 6. Others see 8. The truth is, rainbows don't have fixed boundaries. They're continuous spectrums where colors blend into each other. Newton just drew lines where he wanted to see them. But wait, it gets weird. Human eyes can only detect a tiny slice of the color spectrum. Beyond red, there's infrared. Beyond violet, there's ultraviolet. Every rainbow has invisible colors we simply can't see. Enter the mantis shrimp. This tiny ocean creature has 12 color receptors. 12. We have 3. If a mantis shrimp looked at a rainbow, it would see colors that don't even have names in human language. To them, our 7-color rainbow is like watching a movie in black and white. Butterflies, birds, and bees all see ultraviolet. Humans? We're basically running on limited vision mode, and there's no upgrade available. Here's something that is consistent. The order never changes. Red, orange, yellow, green, blue, indigo, violet. This order is locked in by physics. Red light has the longest wavelength, so it bends the least and appears on top. Violet has the shortest wavelength, so it bends the most and sinks to the bottom. Every other color falls in between based on wavelength. It's like nature's assembly line, precise, consistent, and automatic. But not all rainbows look equally vivid. A bright, saturated rainbow means there are lots of large, uniform water droplets in the air. A faint rainbow? Now let's talk about double rainbows. This happens when light bounces twice inside a raindrop instead of once. Each bounce costs energy, which is why the second rainbow looks fainter. And here's the mind-blowing part. The colors are reversed. In the second rainbow, violet is on top and red is on the bottom. Why? because the extra bounce flips the light path. If you're really lucky, you might even see a triple rainbow. Or a quadruple rainbow. They exist, but they're insanely rare. Basically, the universe is just showing off at that point. Now, here's a thought experiment that'll haunt you forever. What if every person sees colors differently, but we all just learned to call them the same thing? What if your red looks like my blue, but since we both learned the word red for that wavelength, we'd never know? There's no way to test it. We're all trapped in our own heads, seeing our own private version of reality. Same light, different eyes, different brains, different rainbows. For thousands of years, humans have looked at rainbows and tried to make sense of them. Some cultures saw them as bridges to the gods. Others saw serpents. Others saw promises. Newton turned them into science. But even science couldn't remove the magic. Because rainbows were never just about physics. They're about human curiosity. Our need to categorize the uncategorizable. To find patterns in chaos. So here's the truth about rainbows. They don't exist in any fixed form. They don't have 7 colors because physics demanded it. They have 7 because one curious human thought it sounded beautiful. And maybe that's the point. The universe doesn't hand us answers. We create them. We look at light bending through water and say, I see 7 colors. Someone else says 5. Someone else says infinity. And somehow, we're all right. So next time you see a rainbow, don't just take a photo. Pause. Look at it. Ask yourself how many colors you see, because in the end, rainbows aren't about what's really there. They're about what you choose to see. If this video made you see rainbows differently, hit that subscribe button and join us for more mind-bending physics. Quick question before you go. You're at the beach, sweating, dying from the heat. The sun is 93 million miles away. Now you climb a mountain. You're literally getting thousands of feet closer to that burning star. So why are you freezing? Why is there snow? Why does closer to the sun feel like being shoved into a cosmic freezer? This sounds stupid, until you realize the answer flips everything you thought you knew about heat completely upside down. Mount Kilimanjaro is at the equator. The base is tropical. The summit is covered in glaciers. Same sun, same day. How? See you in the next one.